All right, let's take a look at 3 examples of sketching a graph. We might be asked to do something like this. Sketch a graph with the given information and key features. And we might be asked to express what some key features are or something like that. So for a first example, actually I'm going to do 3 examples. So for the first example, we've been asked to sketch 3 cycles of a trig function, so periodic sinusoidal function, with a period of 4 and an amplitude of 5. Let's keep those in mind. The domain of the function is -10 to +15, and to state some key features, we'll worry about all that later. So the domain of the function means we are just limiting what we're going to see. So we're going to draw it from -10 to +15. I have an arbitrary graph here. I haven't really figured out my scale yet, so let's take a look at that. So if I just go by ones, I can actually do that. 1, 2, 3, 4, 5. And we're going to have enough room to do all of the work here. We're going to limit ourselves from -10 to +15. We can decide where we start, and are we going to start on the axis? Are we going to start at the maximum? It really depends if you're a fan of sine or cosine. I tend, personally speaking, I tend to start right on the axis, just something that I do. Now they did tell us what the amplitude is. And the amplitude you can kind of think of like your distance, well not kind of, it's the distance to the maximum and it's the distance to the minimum. As this periodic function comes up, it's only going to ever get as high as 5. So let's keep that in mind. The highest value we're going to get to is 5, and the lowest value we're going to get to is -5. We haven't done any sort of vertical translation here. We could if we wanted to get fancy. So you don't necessarily need your axis of symmetry, or I guess your midline, to be the x-axis. I've chosen to do that. You could draw it so that your minimum is the x-axis. Heck, you could draw this anywhere, and maybe I'll show an example of that later, I guess. Let's deal with the period now. So how many cycles have we been asked to show? We've been asked to show 3 cycles within this domain, and it has a period of 4. Now, if we don't fit 3 cycles, maybe I wrote this kind of quickly, so maybe we don't have to focus on 3, but we do want to focus on the period of a distance of 4. By the time we get 4 across, we should have finished 1 repetition of this thing. So it's going to be kind of squished. It's not a very large sinusoidal function. Now, of course, what's the halfway of 4? Well, it's 2, so 1, 2. And so what that means is I'm going to hit my maximum of 5 right about here. I'm going to hit my minimum of -5 right about here. And 1 cycle of my sinusoidal function, or my periodic function, 1 cycle will go up. It'll come down, hit its minimum, and come back. And so that's my period. My period, let me just draw that out, of 4. I've got my maximum height, or my amplitude, of 5. Same thing with my minimum. My minimum is 5. I have been asked to draw 3 cycles of this, so I'm just going to continue that work then. So I can see that every 2 on my x-axis, something important is going to happen, whether that's crossing through, beginning and ending, anything like that. What did I use? I used blue. So let's go 1 more. So we're going to go up to here. So this would be cycle number 2. And we were asked to do a 3rd cycle. So this one will be cycle number 3. And of course, it's just a sketch, so whether or not it's perfect, who cares? So yeah, the domain doesn't match the number of cycles we were asked to draw. Let's just arbitrarily change that for this video example, and just say that we were asked to draw that function over and over again until we complete it. Until we complete the domain. So we would draw it a couple more times, and as a matter of fact, because the domain is not divisible by 4, we will end at a partial. So let me just get to that 15. And so we're going to end at a max. So, there's an example. There's one example. So it doesn't necessarily have a vertical translation of anything, any sort. If we wanted to draw it slightly different, we could have maybe started higher, started lower. It's really up to you. I chose my x-axis scale to be ones. Maybe you don't go by ones. That's going to depend on what it is you're drawing. Now we've been asked to state some of the key features. What is the maximum? What is the minimum? So that's going to also depend on your drawing. My maximum is 5, so I could just state that here, max of 5. You might want to list this on the side somewhere instead of on the graph so that it doesn't get so messy. I have a min of -5. We've been asked to state what the minimum is. The sinusoidal axis of symmetry, I chose my axis of symmetry to be x equals 0, nice and easy. What is the range? Well, my range, if I can squeak this in here, is y is an element of the reals such that we're going from our minimum, it's not going to fit, to our maximum like that. Pretty easy. And I think I've got one more thing to do, the intercepts. We've been asked to list the intercepts. Now, this example, there's lots of intercepts, -10, -8, -6, etc. So you go ahead and you list those. I'm not going to bother doing that, but you would list your intercepts. Let's take a look at another example. Won't be periodic. So let's do an exponential function with a range of y is greater than 2. Y is greater than 2. So we're focusing on anything above a y value of 2. And, you just draw your Cartesian plane accordingly. I could have not drawn the bottom part necessarily. We've been asked for it to be an exponential function, and it has a y-intercept of 4. So we're going to hit the y-axis of 4. So we have a couple options here on how we want to draw this. We could draw a decay function or we could draw a growth function. If we were to draw a decay function, we might have it coming down from this direction and then crossing at the 4, and then it hits that asymptote at the y equals 2 because of our limiting of the range. If we didn't want to draw a decay function, we wanted to draw an exponential growth function, and I'm not the greatest artist in the world. We might draw something like that. So we have an exponential growth function. We've been asked to state the domain. All right, so my domain for this function, as with any exponential function, unless there's something funny going on, is just an element of the reals. All x values are valid for this. My horizontal asymptote for this particular one, my asymptote is because of the range. My asymptote is at y equals 2. And last but not least, the x-intercept. Well, guess what? The x-intercept was not going to happen. Okay, in this particular example, we have no x-intercept. So there is no real roots or no x-intercept. If we've been asked to draw it differently, if I were to change the range such that it's less than 2, then we certainly would have an x-intercept, and that would just depend on where you drew it, to be honest with you, because this is just a sketch. Third example, last one, a polynomial function with x-intercepts at -5. And you know what, I'm going to go ahead and draw that. X-intercept at -5. Let me switch to red. Another x-intercept at -1 and another x-intercept at 3. Then we've been told what our end behaviors are. Now, if I have an x-intercept over here on the left, and I'm going to take a look at my left endpoint behavior, let's focus on that. If I'm on the far left, as x approaches -infinity, so as we go to the left, this function is going down. It's going to -infinity. So as I go from this intercept to the left, I'm also going down. So I can draw that however I want. It can be fat, thin, however. The right hand endpoint behavior is doing the same thing. So as x approaches positive infinity, the y is approaching -infinity. So we have another drop. So both of the endpoints are going downward. So we have to decide how are we going to have 3 x-intercepts and have this happen. I can go up through this x-intercept, down through this one, and come back and have this one maybe be a vertex so that it bounces off, because I can't add another intercept. I was not told any other intercepts. Is there another way to draw that? Well, what if this one was the vertex and it came back like this, and this one was a vertex and it came back like this, and this one was a vertex? All 3 of them are vertices. There's lots of different options. This could be a vertex, and this one comes up, and then this comes down. So you've got lots and lots of different options as to how you're going to draw this with the given information. Then we've been asked to state the following key features, the domain. Well, the domain for this function is x is an element of the reals. All x values are valid for this. We've been asked to state the range. Now the range is going to totally 100% depend on how you drew it. I decided to have a maximum over here. Let's make that maximum a little bit more specific. Let's make that maximum, and this is the beauty of sketches, right? You can do it however you want such that it meets a criteria for yourself. So let's have a y-intercept of 2 and a maximum of 3. So my range is such that it only goes up to and includes 3. So y is less than or equal to positive 3. I've been asked to state the y-intercept. I purposefully made my y-intercept 2. I've been asked to state the maximum and minimum values. There is no minimum. This goes down for infinity. But there is a maximum, and it's at 3. So I have a maximum of 3. If we want to talk local minimums and local maximums, I do have a local minimum. Right down here, let's call that negative 2. So I could say that I have a local min of negative 2. Okay, so that's 3 different sketches given some properties, and your sketches don't have to match mine. It will depend on what you've been given. It'll be dependent on your scale, your drawing abilities. As you can see, mine aren't all that great either. And then don't forget to list what you've been asked to state.